We start this problem by calculating the momentum of A. What is the momentum of A? Well, it's 40 kilograms times 10 meters per second, and as a direction at 40 degrees south of west. So, multiplying those two guys together, we get 400 kilogram meters per second at 40 degrees south of west. We have a scale of 1 centimeter equaling 100 kilogram meters per second, so our vector should be 4 centimeters long. And it's pointing down, south of west. So now we move our piece of A initial to hit our collision point. We can do the exact same process to get our piece of B initial. It is 25 kilograms, moving at 30 meters per second at 70 degrees north of west. 25 times 30 is 750 kilogram meters per second. Still going the same direction. So this should be 7.5 centimeters long. So I move my piece of BI to hit our collision point. And I just do the exact same process over again for our piece of A final. So now we have a drawing of all three given vectors. Now we have to figure out what piece of B final is. How do we do that? Well, remembering our conservation of momentum, piece of A initial plus piece of B initial should equal piece of A final plus piece of B final. Now I know some of you want to add the magnitude of the momentums together. I've seen some people say 400 plus 650 equals 600 plus piece of B. However, this does not work because we are working with vectors. We have to use the head-to-tail method to add our vectors together. So we can figure out what we need to do by doing some simple algebra. We want to isolate piece of B final, so we'll just take piece of A initial, piece of B initial, and then we'll just subtract piece of A final from both sides. This is where we bring in the ghosts. Just going to take a copy of piece of A initial and move it over here. I could also take a copy of piece of B and move it over to the top of piece of A. This gives us the piece of A initial plus the piece of B initial. Now we just need to subtract piece of A final. We'll take a ghost copy of piece of A final, and instead of just adding it like this, we're going to subtract it. We subtract it by flipping it upside down. Now we can take our ghost and move it so we can add them head to tail. So we successfully subtracted PA final from PA initial and PB initial. We've completed all three steps of our vector addition. All that remains is to draw in our head to tail, our little R. This R right here is a ghost, so we want to move him up to where he belongs. We have found PB final. Now all that remains is to measure how long this little guy is, and I got 1.3 centimeters. Using our scale of 100 kilogram meters per second equals 1 centimeter. This gives us 130. And I got an angle of about 20 degrees south of east. Because this is a head-to-tail method, it's not super accurate, and we'll make tiny errors that will add up, especially when we have such a tiny resultant. In order to get our final answer, we need to take that 130 kilogram meters per second and break out the parts of the suitcase. So because P equals mv, we can take this and divide it by the mass of the object. The mass of B was 25 kilograms, so we divide those units, will cancel out, and we'll get a final velocity of about 5 meters per second. Writing it all out properly, we'll say 25 kilograms at 5.2 meters per second at 20 degrees south of east. And that's our final answer.